And
Hey, how's it going? Happy to be here.
cool. Actually, first of all, maybe I don't think people know this that Aaron and I had the same
Be here.
advisor
Cool.
in our
Actually,
PhD
first of all,
program at Princeton.
Yep.
So, Aaron, which year did you start? I started in 2008. You might have been 10 or 11.
Hey, I think I was 11. I want to say 11. Um, Timelines tend to blur in grad school. Like
Yeah.
if really asked, I couldn't tell you when I graduated.
I think you definitely graduated after you were working on Blockstack. I
Yes.
remember.
Yeah.
Cool. Awesome. So thanks everyone for being here. I think we have over 60 people here right now. That's great. Hope you guys were able to read up on the stacking SIP that came out. I think on purpose, we haven't made a big deal of that yet. I haven't announced it anywhere broadly. We just kind of like very much like just shared with the community, mostly because we are looking for feedback on it. And we are looking to hear what people think about the proposal, and then we are iterating over some of the core designs. But let's kick things off, and I think we will have a list of questions, or Mitchell or Jenny, if you want to kind of like intro the format a little bit, that would be very helpful.
Yeah, hey, this is Mitchell. We're going to start just with Aaron's presentation, and then we've been sourcing your questions via the website and ongoing discussion on Discord, which the link is there in the chat. I think we can go ahead and get started with that.
Yeah, cool. All right, so now we get to live debug whether or not I can get screen sharing working. Let's see. Okay. All right. Does everyone see a presentation?
Yep, I see it.
Yes. Cool. All right. Okay. Hello, everyone. So again, I'm Aaron Blankstein, and I'm going to be talking about SIP 007, which proposes the stacking consensus algorithm. Before I get into really the body of my talk, I have to give you this important disclaimer slide. I'm not going to read through it for you, but it contains important information you should probably read, and we're going to distribute the slides after the town hall is over, and this will be in there so you can read it then. All right, so first I want to tell you what this talk is going to be about, and also maybe what this talk is not going to be about. It's really why I'm giving this slide. So the things I'm going to cover here are basically what the stacking consensus algorithm is, what the problems are that it's designed to solve, and how it goes about solving them. So sort of the technical details of these three aspects. Things that this talk is not about are basically the economic forces at work in stacking. I'm bad at econ, and there's probably better sources and people to ask questions of for those kinds of questions. I'm also not really going to talk too much about the motivations for stacking, because that kind of gets subsumed into the econ questions, and really I'm sort of more concerned about the technical details anyways. All right, so with all of those sort of caveats out of the way, we can sort of start to dive right in. Okay, so SIP 007 is a proposal that, if adopted, would introduce the stacking consensus algorithm into the Stacks V2 blockchain. This consensus algorithm uses a novel mechanism called proof of transfer. You can think at a very high level of proof of transfer being sort of a simple modification of proof of burn mining, where instead of destroying the committed Bitcoin, that Bitcoin is transferred to Stacks holders. I'm going to give you sort of a high-level overview also of how proof of burn mining works. So if you're not sort of fully aware of how that works, I'll talk about it in a minute. But if you want more details on proof of burn mining, you should really see SIP 001 or the Blockstack white paper, because those are kind of the best sources of information on that. Also, I do try to cover a lot in this talk, but really SIP 007 is the best source for a lot of the details of how proof of transfer and stacking works. All right, so I'm going to start with sort of introducing proof of burn. So in a proof of burn system, miners are competing to form new blocks, new stacks blocks, by announcing block commitments on the Bitcoin blockchain. So these miners are announcing these block commitments, and stacks nodes are using those block commitments to perform a leader election for each stacks block. Now, each block commitment is scored by stacks nodes according to the amount of Bitcoin that the miner burned and the amount of work that the miner performed to sort of prove that block commitment. Once those commitments are each scored, the leader is then chosen through a cryptographic sortition, which is really just a random selection weighted by the score. There's one leader chosen for each stacks block, and that leader is able to form the stacks block for that period. One of the sort of important things that's happening in proof of burn is that stacks nodes are able to verify all of these leader elections entirely with data that's available on the Bitcoin blockchain. Okay, so what does this process, I guess, look like as a flowchart? Maybe people are more like graphical thinkers. I know I am. That's why I wave my hands around every time I talk. So here in a proof of burn system, you have miners. These miners are sort of committing Bitcoin to burn addresses in order to participate as miners. Those commitments are used as inputs to the leader election algorithm. The leader election algorithm chooses a single leader, and finally that leader is able to assemble and broadcast a new stacks block. Let's maybe look at an example of what an election would look like. So here we have a leader election to form the next block in the stacks blockchain. So here the stacks blockchain currently has 3 blocks, 1, 2, and 3. And then we have 3 miners, A, B, and C, who are competing with each other in order to form the next block. So miner A burns 1 Bitcoin, and they commit to building off of block 2. Miner B also burns 1 Bitcoin, but they're committing to build off of block 3. And miner C burns 2 Bitcoin. Based on these burns, each of these commitments gets a score relative to each other. So A and B's score is the same, and C's score is twice their score, so it's 0.25, 0.25, 0.5. Based on those scores, each miner claims like a sortition range, because remember, we're going to do this sort of random selection weighted by their scores. And the way that works is you basically just pick a random number between 0 and 1, and whoever claims that range wins. So here, let's say that the random sortition value was like 0.45. What that means is that miner B would win, and they get to build the next block. So here, miner B builds block 4, and it's a descendant of block 3, because that's what they committed to. Cool. So that's how proof of burn works. Now, proof of transfer, you can think of it as like a very high level. It is a modification to proof of burn, where instead of burning Bitcoin, you send it to stacks holders. So what does that look like in sort of the same flow chart? So here, as a first step, you have stacks holders who are broadcasting signed statements and completing some set of requirements in order to participate in the proof of transfer process. Those signed statements are used to form a reward set. And then miners, just as in proof of burn, they're committing Bitcoin in order to participate as miners. But here, instead of burning it, they send it to the reward set. And then the process kind of follows the same process as proof of burn. We have a leader election algorithm where the commitments are used as inputs and a sortition is performed. A leader is elected and they get to assemble a new stacks block. So the important question when it comes to proof of transfer is like, how do nodes agree on what this reward set is? That might seem like maybe like a simple problem to solve, but it's actually quite tricky. So reward set agreement is kind of a hard problem. And the reason for this is that the reward set is only valid in the context of stacks data, right? So these signed statements by stacks holders, they can only be verified by looking at the chain state of the stacks chain, not the Bitcoin chain. And despite that, leader election and mining is still occurring on the Bitcoin chain. So there could be problems where, perhaps the stacks chain forks or there's missing data, something like that, where interactions between the stacks chain and the Bitcoin chain, any problems with those interactions need to be safely handled by stacks nodes. And we want to handle these things in such a way that you limit the likelihood of these kinds of problems occurring. And you also reduce the feasibility of intentional attacks by would-be malicious actors to try and exploit these problems. So I'm going to dive in with a little bit more detail of what one of these kinds of problems is by looking at an example. So here we have an example of a stacks fork that could affect the reward set. So in this example, we have two forks, fork A and fork B. In fork A, Alice has received from Bob enough funds to participate as a holder in the next reward set. And she broadcasts a signed message to participate. So in fork A, Alice is going to be in the reward set. In fork B, Bob actually spends those funds that would have been sent to Alice. So in this fork, Alice doesn't have enough funds to participate in the reward set. All right, so you have two forks, and then we have two miners, which are mining off of these two forks. Miner A is mining off of fork A, and so in miner A's commitments, they send funds to Alice. Miner B, they're mining off of fork B, and so they do not actually ever commit funds to Alice. So now we have a problem because miner A and miner B actually disagree about the validity of each other's commitments. And now they don't know how to interpret the sortition results in sort of consistent way. So this is sort of the fundamental problem that the stacking algorithm is going to try to solve. All right. So what is the stacking consensus algorithm? The stacking consensus algorithm is really a two-phase cycle where stacks nodes engage in a prepare phase followed by a reward phase. In the prepare phase, all of the stacks nodes come to agreement on the reward set and the rules for validating Bitcoin commitments. In the reward phase, stacks miners commit new blocks to the stacks chain using those rules from the prepare phase. And one thing to note about these is that these cycles actually overlap such that one reward cycle may be in its reward phase at the same time that the next cycle is in its prepare phase. So we kind of stack these over one another. Cool. Okay, so what actually happens in the prepare phase and what are these things being decided on? So the prepare phase is a window of Bitcoin blocks before the reward phase begins. Like for example, 240 Bitcoin blocks, it's like a lot of Bitcoin blocks that determines two things. So first, nodes are going to come to agreement on something called the anchor block. The anchor block is a stacks block that for the entirety of the following reward phase, miners working on any descendant of the anchor block will mine by transferring funds to the reward set. So you can think of the anchor block as sort of the marker for the forks that will be participating in proof of transfer. Then once the anchor block is decided on, nodes come to agreement on the reward set, which is just the set of Bitcoin addresses that will receive funds during the subsequent reward phase. Okay, so how is the anchor block chosen? Well, at a very high level, during the prepare phase, nodes are looking to see if any of the blocks that existed right before the prepare phase begun were confirmed by F times W blocks during the prepare phase, where F is some large fraction. And the sort of the exact algorithm for choosing this block is included in SIP 007. So I won't go into too much detail of the algorithm, but there's two important properties of this anchor block. So one is that for any prepare phase, only at most one such block will exist. The second important property is that the anchor block is at least W blocks old when the reward phase begins. So it's had some time to sit in the network and for everyone to see it. It's also been confirmed by a very large fraction of the network's mining power. Right, so once these nodes determine that there is such an anchor block, they then further validate this anchor block by looking for stacker support. So what stacker support is that all of these would-be stacking sort of participant users, they send out these signed messages that indicate support for an anchor block. And any anchor block that will eventually be chosen must pass some threshold of support signals. So you can think of these two requirements as, on the one hand, an anchor block needs sort of sufficient miner support. And then on the other hand, an anchor block also needs sufficient support from stacks holders. Okay. So once the anchor block is chosen, we can start to figure out what actually comprises the reward set. So in order to determine the reward set, nodes are looking for signed messages from stacks holders. So stacks holders that send out a signed message must first qualify for being in the reward set. In order to qualify, they must control a stacks wallet with greater than or equal to 0.02% of the total share of unlocked stacks tokens. Today, I think that would be around 94,000 stacks. The reason that this is kind of like a variable requirement is because over time, the stacks token supply inflates a little bit. And we want these reward cycles to be like fixed length cycles. Okay, so if you're a stacks holder and you qualify to participate in the reward set, you broadcast a signed message. That signed message will lock your associated stacks tokens for sort of a protocol specified lockup period. It'll specify a Bitcoin address that should receive your funds, and it also signals support for a stacks chain tip. The validity of all these signed messages has to be verified using the anchor blocks chain state. All right. So once the prepare phase finishes, the stacks network can move into the reward phase. During the reward phase, miners are competing by broadcasting block commitments, and these block commitments are scored according to how much Bitcoin they send to valid addresses. Address validity is determined by like one of two rules. So first, if you're a miner and you're building off of any chain tip that is not a descendant of the anchor block, the Bitcoin that you're committing must be burnt. So it has to be sent to a burn address. Otherwise, if the miner is building off a descendant of the anchor block. The miner sends their committed Bitcoin to 5 addresses chosen from the reward set. The way that these addresses are chosen is that they're sort of selected randomly out of the reward set using a verifiable random function similar to how we do sortition. And they're chosen without replacement. So once an address comes out of the reward set and is an address that receives Bitcoin for 1 block of the reward cycle, they don't get selected again for the same reward cycle. Now, if during the reward phase, if for some reason anchor block data is missing, Stacks nodes treat the reward phase as if no anchor block was chosen at all. So basically, they fall back to a proof of burn system. Okay, so with that, the prepare and the reward phase, we can kind of see how stacking consensus works. So let's maybe revisit that forking example from before, the problematic forking. So in this example, remember there's 2 Stacks forks, A and B. In A, Alice is a valid recipient for the reward set. In fork B, Alice is not in the reward set. So what this would look like is here we have 3 blocks, 1, 2, 4, which form fork A, and then 1, 2, 3, which forms fork B. After these 2 chain tips, 4 and 3, the prepare phase begins. During the prepare phase, fork A actually receives 200 confirmations, and then the reward phase begins. So because block 4 in fork A received 200 confirmations, that was enough for that block to be chosen as the anchor block. So now that that's been chosen as the anchor block, in the reward phase, miners are treating that anchor block as sort of the rules governing where to send their Bitcoin commitments. So here, let's say we have 2 miners. Again, miner A, they're building off block N. Block N is a descendant of the anchor block 4. So miner A sends Bitcoin rewards to Alice. Miner B, who's actually just maybe really interested in extending fork B, they're building off of block 3. Block 3 is not a descendant of the anchor block, and so miner B has to burn all of their commitments. Cool. And then very abruptly, I'm ending the talk. I probably should have had a conclusion slide of some sort, but I didn't. So yeah, so that's sort of how stacking consensus works. That's kind of the set of problems it's trying to solve. And that's also how it solves them. But yeah,
awesome.
While I
thanks, Aaron. Yeah, so I think this was kind of like the more technical lens on this, and as Aaron kind of like gave you guys a heads up that he was staying away from any kind of like economic mechanisms and incentives around this. And I'm noticing a bunch of questions in our Discord about what are the benefits, and why are we doing this at a very high level. And I think it might be helpful to zoom out a little bit. And basically, I think of this as, I've been in the crypto space since, I would say, 2013. And back then, you would see different types of proof of work blockchains starting up, right? Believe it or not, Namecoin used to be the #2 cryptocurrency back then. And I think Namecoin has since completely disappeared from the charts. And all of these different blockchains were trying to fork Bitcoin to add some functionality and start their own proof of work blockchain, right? And they would go through this problem of like, there isn't enough hash power. They would try things like merged mining. We actually discovered problems with the merged mining approach on Namecoin, published some research around it. But it's almost like a fundamental thing in the crypto industry where people want to build things different from Bitcoin, but they always have this problem of starting a new proof of work thing that is not very secure, right? Or there isn't enough interest from miners, because we do see consolidation of mining interest going towards one king kind of like proof of work chain, which is clearly Bitcoin. And people have started doing other things like proof of stake. Even Ethereum is still on proof of work, trying to switch to proof of stake. And there are certain kind of like downsides to proof of stake that make us not comfortable with proof of stake. I wouldn't go into the technical details, but it basically, at a high level, we are convinced that proof of work is more secure, more has less like bootstrapping problems and things like that. I think the work we have done with stacking, or what we are calling proof of transfer, POX, in a way is best of both worlds, right? It gives you the security of proof of work because you're anchoring on the most secure proof of work chain, but it gives you certain very interesting economic benefits of proof of stake, where the existing holders who are doing some work for the network can actually get a payout from the network. And I think those economic incentives are very interesting. And we have seen that play out in the last couple of years with certain projects that were actively doing staking, like Tezos, Cosmos, and others. One thing where this is very different from traditional staking is that the payout is not in stacks, right? And the payout is actually in Bitcoin. And I think the way to model this is you're kind of like saying that Bitcoin is digital gold, and we accept it as digital gold, and our payouts are going to be in this digital gold. And having these two different types of crypto assets actually introduces very interesting market dynamics here that we are at a very early stage of exploring, and I think people are trying to model it out. But we are super, super excited about I consider this a breakthrough in terms of there's a fundamental tension in the crypto industry where how Bitcoiners would not like if mining power for proof of work is going to other chains. And what we're really saying is you can accept Bitcoin as the thing that won the proof of work war, and other blockchains can just anchor on top, but can have a very sustainable, healthy relationship with the underlying base cryptocurrency instead of kind of like being at odds with it and try to compete with it. I think with that, maybe we can start opening up to some of the questions as well. Maybe Jenny can help there.
Yep, thanks, Munib. So yeah, just on the point about zooming out, there are obviously a lot of exciting developments on the docket for the coming year. So we did actually have a question from a community member, Vishnu, about the things that we're most excited about, especially in the next 6 months. Oh.
We may have lost Jenny, but I believe the question, Munib, was what are you excited about in the next 6 months related to Stacks v2, stacking, et cetera?
Yeah, so I think in the next 6 months, first of all, the SIP is at a proposal draft stage right now. Regardless of the new SIP 007 proposal, we were actively working on the launch of Stacks 2.0, right? So think of this as Stacks 2.0 launch was happening anyway, and this is a major potential improvement and upgrade to the Stacks 2.0 launch. So I'm super excited about the 2.0 launch because in many ways, that's the blockchain that we always wanted to build, right? So it's a complete rewrite. I actually think that most of our community is not even aware how much work Jude, Aaron, and other people on the blockchain team have done on this. So it's a complete rewrite in Rust, which is a great language for programming kind of like secure layers like blockchains. And over there, that's the blockchain where we will be introducing the Clarity smart contract language. Again, Aaron and others did like amazing work on the design of the smart contract language. And for the first time, our ecosystem will have predictable smart contracts where that developers can play with. They can have like some features that we've seen a lot of demand for. So Stacks 2.0 by far is the biggest thing that I'm excited about in the coming 6 months. The other things, and I think this is where I need to be more careful because they kind of like overlap with certain regulations. But for since 2017, and even in our SEC circular, we've been very clear about our path to further decentralization, right? So we've been, even in our SEC circular, if you go and read the paragraphs there, we've been very clear that Blockstack PBC actively plans to work on further decentralization of the ecosystem. And I think there are certain things that I can't publicly talk about right now, but they're in the general category of further decentralization. And that's something that I'm extremely excited about, because we truly need to operate as an ecosystem and as open source software, and not as something where Blockstack PBC is a company that is just working on this, and the community has this expectation that PBC is the only entity that is going to make major decisions or do the bulk of the work. So in many ways, I think the path to decentralization is PBC handing over responsibility to other entities, and more importantly, the ecosystem, right? So I've seen great growth in our community in the recent months, and that's very exciting, because I think that goes hand in hand with further decentralization. As PBC gives up certain roles, other people need to pick that up, and I think the best people to pick it up is actually our open source community.
Awesome, thanks for that answer, Muneeb. The next one is from Adam Savage. He asks, I know there's the app mining program going on, but what other learning opportunities will there be for devs to learn Clarity?
So I think app mining, we should bucket it as a separate thing, right? App mining, think of that almost as a dev fund that is automated. Like we can run an algorithm based on metrics and kind of like use the dev fund for it, instead of doing it manually or running it as a more traditional dev fund where people are just manually deciding like where should the allocation go. So app mining is separate. Think of this as the Blockstack ecosystem should have resources for education, for developers, and people should be able to build on top of Blockstack regardless of app mining, right? App mining is almost like a booster, right? It's additional fuel to incentivize developers, but there should be incentives for people to just build more private, more secure applications, or build interesting Clarity smart contracts. So I'll completely separate it out. And yes, we are working on a bunch of Clarity tutorials. We are actually also engaging with other third parties or other players in our ecosystem, because I think, again, Blockstack PBC should not do all the work. It's actually very important that the designers of the language, like Aaron, are also not users of it, right? Like we really want our developer community to actively engage with the initial use cases and tutorials of Clarity, help us improve that, because that's how we learn, right? Like that's an iterative process where our documentation gets better every time more developers kind of like engage with it and truly approach it as an open source resource.
Great, thanks for that, Muneeb. Another question from Frieger. How do you see dApps integrating decentralized identities in storage in the future?
I missed the first part, like what integrating?
How do you see dApps integrating decentralized identities in storage in the future?
I see. Let me answer this at a more high level. I think the reality on the ground is that right now there is the default client, which is the Blockstack browser, and there is the default Gaia hub that Blockstack PBC runs, right? That is a good start, but that's not where we want to end, right? Like by far, that's not the place where we want to end. In a more healthy, more developed ecosystem, what we would like to see is, first of all, like many options for the actual data vaults, right? Like where are users keeping their data? It should be their choice, right? And they should be able to easily keep their data encrypted and privately wherever they want to keep it, and not be dependent on just one Gaia hub run by a single company, right? So that's one piece. It will require a lot of work. There are many kind of like sub bullets there. I wouldn't go into them, but you can think of that as almost like a work stream, mostly around decentralized storage, and that should take place in the coming years. And about authentication, I think it's a very hard problem. I do think Blockstack has one of the best solutions in cryptocurrency right now, but the bar is not very high, right? Like it's like we shouldn't be satisfied that, hey, our auth is like so much better than every other decentralized auth. I think we should be comparing ourselves to just normal auth, which you know, most of the internet users are used to, and we should admit that our authentication is more complicated because, you know, it's decentralized and people need to learn about private keys. So I think there is already ongoing work on making the authentication process more simple, but in the slightly longer term, my expectation is actually that there would be different types of providers available. Like there can be like a quote unquote Coinbase like entity, for example, that can actually be managing private keys for people, and maybe that's fine. It's an option that they have where they are kind of like letting a third party manage something on their behalf, and they can exit from that third party if they're not happy. And then there will be people who are absolutely paranoid about these things, and they're like, no, I have different levels of security that I set for myself, and I want to manage everything directly myself. And I think even for those people, they should have multiple choices. It's not like there's just one default software that they're dependent on. I think there should be multiple options. And again, connecting this back to paths to further decentralization, I think these things go hand in hand, both on the storage side and on the authentication side.
Great, thanks for that. And I think just for the community members in this call now, we do want to unmute a few of you. It looks like some of you have raised your hands, so you have questions to ask. I see one from Shohel. So Shohel, please feel free to ask your question. Nope. Are you there?
Maybe we need to unmute.
No, it looks like not.
They're on chatting.
Yeah. Okay, looks like we can't hear them. I'll take another question from community that was submitted. So we had a question from Adrian Groper. Where are Blockstack's plans relative to decentralized identifier standards like the ones from W3C?
Yeah, so Blockstack was actually super early in the standard space. I think this was like early 2016, where we partnered up with Microsoft to help start the Decentralized Identity Foundation. I personally served on the working group on naming and identifiers. I saw the beginning of the DID standard that's relatively more popular now. And I think we were thinking of engaging W3C and other such standards bodies back then as well. I think one thing to keep in mind is the core Blockstack team is a set of builders and engineers, right? So that is slightly different from people who enjoy working on standards a lot, right? They might not be writing code all day or actually building the real systems. They're working on it from a different angle. They're trying to standardize things, and they're trying to come up with formats and stuff like that. So our team does the best work when we're building and executing and actually shipping things, and that's what we did. Our commitment to Decentralized Identity Foundation is that we are going to go ahead with some version of an identity standard that we think is reasonable, and we're just going to ship code. And we will make sure that whatever standards eventually get finalized through these bodies, we will try to be compatible with them, right? So that's the relationship we have with standards bodies like W3C or Decentralized Identity Foundation. With that said, I think they have done a lot of work recently that we kind of like need to catch up on a little bit. And we were very early, but we also didn't engage that actively in the recent years because we were very heads down building the core software.
Great, thanks. And we've got another question from Brad on stacking. So he's asked, was this mining consensus algorithm discussed formally by, say, game theory and blockchain experts, Bitcoin core guys, and others?
Yeah, so I think there's a list of people that we are contacting for getting reviews on this. Some people that just happen to be friends of the Blockstack project. For example, they're professors at Princeton. Mike Friedman, who's a distributed systems expert. Arvind, who's on our advisory board for one of the Blockstack entities, and he does a lot of work in game theory, security, privacy. They even discovered potential long-term Bitcoin game theory issues as well. And I think we are using our resources to reach out to domain experts, but we obviously, one of the reasons for putting this out early publicly is that more eyes can go on the kind of like core consensus algorithm, corner cases. The community should take a look at it. There's a separate issue of getting audits for the actual code. We have our own experiences and learnings. There are certain security firms that we like more, and we usually engage them to audit our testnet and then all sorts of weird corner cases that they play around with. Our plans are that it's SIP 007 is a draft right now. We'll get a lot of eyes on this. We will then we plan to publicly or more broadly launch this. I would say like some weeks from now. And then, slowly kind of like increase the eyeballs that we are getting on the work while we are engaging the experts in parallel.
Great, thanks for that, Manib. Another question from Peter T. So just in light of the conversation around taking more of an ownership culture by community members, he asks, where would you say a community can help except at mining feedback? So you mentioned before, there was hope for a bigger ownership culture. What concrete steps would you like to see? So focus on apps, running Blockstack nodes, et cetera.
Yeah, I think I will categorize it into a couple of things. One thing is actually very basic, and it might be something that everyone feels like, hey, I can do this, and I don't need to be an engineer to be able to contribute there. I think if you look at Blockstack as a project, obviously I'm biased, but my viewpoint is that we are one of the teams that has actually delivered a lot of what we set out to do. We have built out real systems. We have kind of like met our milestones. We have built out real applications that can scale out to millions of users. And I think in many ways, like we have created a lot of value. I think areas where we have been weaker at is actually communications and marketing, in the sense that taking the word out to a broader audience. And I think it's even visible on things like our GitHub. Like imagine that there's no community maintained wiki even or information where, like imagine that people like myself, Aaron, and others who are too close to the work sometimes are not the best people to also write the documentation for that work. Or maybe they're too busy trying to do that they can do a good job at actually defining some of these things. So there's a lot of knowledge and a lot of potential that is basically hidden and deep in our GitHubs or deep in our other types of communication channels, and we're trying to open up more. And I think the best thing the community can do is help us do that, right? Like be more active on our GitHub, start maintaining community-driven information resources, telling people about all the work that is going on here and how they can help, because the community is eventually what is going to make or break this project, right? The Blockstack core team is very small compared to how big the community is. And I think from our side, we can try to enable the community as much as we can, like whatever, there should be some sort of a clear division that here is the type of work that Aaron should focus on. And here are the things that these 10 community members can do to help Aaron do what he does best, right? So I think those sorts of things would be number one. App mining feedback is something very very much top of mind. I'm already seeing some really good kind of like input, feedback, and mechanisms coming in there. That'd be number two. And number three is the launch of Stacks 2.0 is by far the biggest thing we have done in a long time. And actively participating in that launch, either as a miner or as a stacker, and helping us improve that launch, because the launch is not going to be like, suddenly out of nowhere we come out and we're like, we're going live. It's going to be test nets, it's going to be initial versions of software. People are talking about potentially creating pooling software, and incrementally together, we are going to improve these things, iterate over them, test them, and then finally get to a stage. And we are moving on Blockstack time, which is like execute fast. I'm talking about a couple of months, not years. So I think any part you can play in that big Stacks 2.0 launch would be super helpful to us.
Great. And a final question from Harini on stacking. So she's asked, what is the reward window period for all those participating in consensus, such as Stacks miners and Stacks holders, and for users supporting leader election?
Yes. So I think we run on blockchain time, right? So when we say approximately a month, that's actually approximately a month based on blocks, right? So time is measured in blocks. So the idea is, the core idea behind stacking is that Bitcoin has a limited bandwidth in terms of how many transactions can be sent over Bitcoin, right? Because people who are stacking are earning their payouts in Bitcoin, those transactions need to happen at the Bitcoin layer, right? So we have kind of like optimized the algorithm in a way that roughly every participant can get one payout per cycle, and a cycle is roughly a month. So I think what the UX looks like potentially for Stacks holders is that there's software that they download, and they sign messages proving that I have like 100K or 200K, whatever is the amount, or if you're pooling, you kind of like work with a pool of Stacks holdings, and then you are kind of like opting into the consensus algorithm, and you're signaling certain useful information on the network. Useful information in the sense of like, what do you think is the right Stacks fork? And that information is very valuable to miners and other people in the ecosystem. So when you do that work, you have kind of like, you are now part of the round, and the round goes on for roughly a month. And during that time period, Bitcoin payouts would appear in your wallet, right? And to me personally, like that's a very exciting thing. I'm looking forward to like running the software and actively participating in the consensus algorithm myself if the proposal gets merged into the main 2.0 branch and we kind of like implement it.
Thanks for that, Manib. A question from Shankar. Hey, Shankar. He says, I understand you had mentioned that for improving the Blockstack login method, it would be good if people can opt for other vendors like Coinbase. So he's asked, are there any other entities to store the keys for us and opt out of it?
Yeah, right now there aren't. And I think going back to communication as well, I think we should really look at Blockstack as software for a user-owned internet. And there are many different layers. That's why it's a stack, right? That's the original motivation for calling it a stack. There are different layers of the stack. All the stuff that we're talking about regarding to the Stacks blockchain, it's basically at the foundational layer, the base layer, right? And authentication is actually pretty high up in the stack. And I think what I'm talking about is that there can be the core protocol that everyone agrees on, but there can be many different clients. And we are internally trying to almost like force that direction a little bit more. For example, for this 2.0 launch, we are thinking that instead of like building one default wallet, the Blockstack engineers would focus on just the core libraries. and let other entities or other third parties or wallets or exchanges kind of like build the different types of wallets and different types of options. And I think that's a good potential strategy for the wallet launch for stacking. But it's also the same strategy that can be used for auth as well, that you just focus on the core libraries and then let different people integrate those core libraries and come up with different types of solutions.
Okay, thank you for that too, Vineeb. And another question from Kevin, who asks, Vineeb, which Blockstack dApps are you most excited about and why?
Yeah, so I get that question a lot, and I usually don't really answer it in the sense that, you know, I don't want to pick any favorites. But what I do answer is that there are certain apps that I actually end up using more often, like either daily or definitely like every couple of days, I would use them. They would be Dmail. Like I actually talk to people there. People email me quite often, and they're surprised that I'm sometimes more available on Dmail than actually regular email. And Mumble is another, like I pop in there once in a while. I use it. I've looked at Graphite in the early days. I had a bunch of docs there. I really like the concept of BlockSign, where we have actually signed some legal documents with people in Asia there. So it's basically, I look at that not as like, hey, what I'm excited about, but I take the lens of like, what is useful on a day-to-day basis to me, and where I keep going back to the app for that functionality.
Awesome. Okay, so I wanted to be mindful of everyone's time because we're scheduled until 4. So, Vineeb, do you have any comments that you'd like to end on, or a note that you'd like to end on? And obviously, discussion will keep going in the Townhall channel and Discord. So for anyone whose questions weren't answered, we can address them there.
Yeah, so I think one thing we can do is that we can, Jenny can definitely help in going through the questions that weren't answered. We can try to answer them in a written format, either on our Discord or our forum. I think my biggest kind of like asks for the community would be that, especially in the coming months, we are actively trying to give more ownership to the community. And I think the Stacks 2.0 launch just happens to be a very natural point for that, because imagine that mining starts there. Before, we were just piggybacking on Bitcoin miners, but for 2.0 to launch smoothly, independent miners need to come in and kind of like actually initiate the launch. Blockstack PBC can't do it, right? So it's a very nice kind of like transition point for us as a community, where not only that, you know, miners become the operators of the network and they're independent stacks holders that are participating in consensus, running full nodes, it starts pretty much like looking like a healthy decentralized ecosystem. I think that's happening at the blockchain layer, but we should try to make the similar things happen at the rest of the stack. That includes our GitHub repository, that includes our knowledge base, that includes kind of like how people, like, you shouldn't feel like customers. Like Blockstack PBC is not a company and you're a customer of it. You should feel like owners, right? Like you are an owner, especially like for those of you who own stacks as well, you have a vested stake in the success of the ecosystem, and you should really act that way, right? And Blockstack PB, and shouldn't look at Blockstack PBC for everything that should be done or can be done. And I think the community should really, really drive like future progress. Thanks a lot for your time. I think it's super exciting whenever, you know, you guys take the time to come to our meetings. I think we had an app mining call, more than 60, 70 people showed up there. I think at the peak, maybe we had 90 or so people today. And it's very, very energizing for us. It basically signals to us that the work that we're doing is very important. People are paying attention, and it really, like right after this call, like I'm super energized and excited about what we're doing. Thank you so much.
Thanks, everyone. We'll be sending out a summary of this call and obviously sharing the recording too. Have a good rest of the week. Thanks, Vineeb. Thanks, everyone.